This question for all of you. Okay, now let me draw an object here. This is a disk. Assume that this is a disk which is rotating. Okay, so rotating with omega. So obviously, it is a free body. So obviously, it should rotate about its center of mass. Okay. Now, so if I take a particle here, and if I take a particle here, so what will be the velocity vectors associated with these two particles?
Omega.
So obviously, velocity vectors.
Yes.
Okay. So let me take this for two particles on the circumference of this disk. Okay, and the radius of this is r. So what will be the velocity of this particle 1 and this particle 2?
Omega and omega.
So you will definitely say this velocity is like this. Okay, and this velocity is like this. Correct?
Yes.
And modulus v1 bar is equal to modulus v2 bar is equal to what?
Omega.
Omega
R.
Correct? Fine.
Yes.
Now this is the condition. Wait. Now supposing I take any other particle, any two particles here, and join it by a line AB. Okay. Now, what happens to this line as the disk is rotating? It will also rotate. So it will also rotate. Now, what is the angular velocity of this line? If the disk is rotating with omega, what is the angular velocity of this line?
Omega.
Why? Why do you say it is omega?
Simple.
Why? How? Justify.
All particles. This line is on that body.
Every point of
All
this.
particles.
Every part, one of you, yes. Now you answer it loudly.
So since this line is on the body cell,
Mm-hmm.
and all particles of the body will have same angular velocity,
Hmm.
so the line will have same angular.
Line also have same. Yes, Neela. What is your? How do you say that this line is also having same angular velocity?
So it is the line, every particle of the body has the same angle, same as the potential.
Amma, see, now you see, why are you using the word particle here? I don't understand. See, particles will have net velocity. Understand? Particles will have net velocity. Understand? So yesterday you see, if I say particle means it has two velocity components. One due to rotation, one due to translation. Of course, it is not translating, so therefore the only velocity component that is there is because of the rotation. That's fine. Now, the question is, how do you say this line is also having angular velocity omega? Something you say, and let me be convinced that you have understood that.
So we'll take
Sir, any linear dimension on the body will undergo the same angular displacement in same times.
Excellent. So the best way is that you see this particle 1, it starts here at say time t1, and then it goes back and comes back to this at time t1 plus t. And if you notice this particle, this one, okay, so this will also undergo a rotation. So it will rotate, and again it will come back here. So if you say its journey started at the same time t1, it will also come back to its original position after time t. Okay, and therefore you see in a way we can say that the angular velocity of any line that you draw here will be same as the angular velocity of the body.
Yes.
Clear?
Yes.
Hello. So here again you see, so that's it. That's very important as far as the motion is concerned. Now if this body also has a translated velocity, so the first and foremost thing is we go to the center of mass and we say yes, it has got Vc by here. Okay, and now you see every particle here you have to attach this velocity vector. Understand? Every velocity vector you have to attach this velocity vector, and therefore the velocity of this particle will be vectorial sum of these two.
Yes.
The velocity of this particle will be vectorial sum of these two. Okay, and needless to say, this center of mass, okay, will have only one velocity component. Correct? In this case. Hello?
Yes, sir.
Yes.
In this case, it has got only one velocity component, that is Vc, because it is freely rotating. And now in this case, the axis of rotation is passing through this point C. In this case, okay. And since I say it is also got Vc bar, so this becomes instantaneous axis of rotation. If it is also moving with Vc. If it is not moving with Vc, then it's the permanent axis. Got it?
Yes.
Yes.
And now you see this body is a free body. Okay. Now supposing I will take this as this. There is this body is now, this is the disc which is rolling without slipping. Okay.
Slipping.
Rolling without slipping. Okay. Now here you see in this body it is rolling without slipping. Obviously this is moving with velocity vc bar. Okay. And this is also rotating with omega. Easy to see. Okay. Now here you see at a given instant of time. Now watch out all of you. At a given instant of time, one particle of this body is at rest.
Yes, sir.
At time t. Which particle is at rest?
The one at the
Bottom.
Yes, bottommost particle is at rest.
Yes.
Bottommost particle is at rest. Okay. How do you say it? What is the condition for it to be at rest?
When omega is equal to Vc.
Excellent. So therefore, this particle has got two components. Okay. One component is Vc bar, and the other component is because of omega.
Omega r.
And omega r is in this direction. And when these two are equal and opposite, this will be at rest.
Yes.
So this is the condition which will make it at rest. Okay. Now I can take this point as an instantaneous axis of rotation.
Yes, sir.
I can take this particle as instantaneous axis of rotation, and now from here, if I draw any line, say A, B, C, and if I say this is O, okay, so I will use D here, I will use C here. Okay. Now you can see that the line OA, the line OB, the line OD, all are rotating with same angular velocity omega.
Yes, sir. Yes.
Understand? So that is something that all of us have to understand. Okay, etc. So we are going to develop a good lot of theory to understand these types of motions and many more things about it. I am just giving you this example to just highlight what we have gained in the last class. I will be able to say that this point I can always reference it with respect to some other point, convenient point.
Yes, sir.
So for our convenience, we can choose the instantaneous axis of rotation, but not arbitrarily, but with few justifications, we should be able to do that.